In this video, we'll talk about insertion sort. Okay, first couple of minutes, we'll talk about the insertion sort algorithms, how it works, what is the mechanism it follows to sort the elements in a list. After that, we'll write a Python code for insertion sort. Now remember, if you're students of GCSE, it is not expected that you would be able to write your own insertion sort code by yourselves. Okay, the question's not gonna ask you to write a insertion sort code by yourselves, but you might find some questions in there. They'll give you the insertion sort algorithm, they'll give you the code, and they'll expect that you understand what kind of sorting is happening in that code. So your job gonna be read the code, understand the algorithms, then you should answer some questions. So my advice is always try to understand the code, look at the algorithm. Don't need to remember this, but you should understand when you see one code that it is insertion sort or not, right? But if you are A-level students, of course, you have no other choice but to learn it, but to write independently insertion sort algorithm. So let's start now. The insertion sort algorithms is the simplest sorting algorithm. It is simplest sorting algorithm really, to understand why. Because it just takes each item in turn and puts it in the right place using the first item in the list as a starting point. In another word, you just look at the second item in the list, then you compare it to all items before it. Okay, and then insert the item into the right place, right? Let's look at this example and then we just repeat these instructions one more time. First of all, it compares values in turn, but we're going to start with the second value in the list. Then we're comparing with the value to the left. If the value is greater than the value to the left to it, no change are made, right? Obvious, because they are in right order. Otherwise, this value, the one we are checking, in that case, we're talking about second value now, is repeatedly moved left until it meets a value that is less than it. And the sort process then starts again with the next value. And we just keep continuing this until the end of the list is reached. Okay, look at this example. The second value is 7. So you're comparing with the previous one, which is 9, means we need to change the order. So 7 comes before 9. Then we move to the next element, which is 6. Then we need to compare 6 with 9 and 7, and then we understand, okay, its place should be before 7. So we take it out and then put it before 7 like this. Then you compare the next element, which is 15. We compare it and you see, okay, we don't need to move it. We go to the next element, which is 17. We compare with the previous one. We say, okay, 15 is there, so we don't need to move it anywhere. Then we come to the 5. Now, 5, we see the previous is 17. So, of course, we need to move. Check the next one. It is 15. We need to move. Next one, which is 9, need to move. Next one, 7, we need to move. And the first element, 6, we know that, okay, we need to move this 5 all the way back here. Remember, I never say switch the value, right? We are not switching the value here. We are moving a value. What does it mean? I'll show you a bit extra when you're writing the Python code. For now, remember that we are not any switching happening here. We are just moving the item in its right place. Okay, and after 5 we are checking 10 and we are moving 10. We checking 17, we know we need to move. Checking 15, we need to move. We are checking 9 and say, okay, I don't need to go further than that. So 10 needs to come just before 15, right? And the last element one more time, 11 we're comparing with previous one, 17 needs to move, comparing with 15 need to move, and then we check also 10. So okay, here is the place for the 11. So that way, all of them are at the end in right order. So simply insertion sort, take a value, comparing with the previous one, and then keep repeating doing it if we need to get in the right place, and then we insert that value in its right place. Hence it get the name insertion sort, right? So here is a quick recap. First of all, we have an unsorted list of elements in our hand, and we begin at the second element in the list and compare it the elements to its left. Okay, if the current element the beginning is second, right, is less than the previous element, move it to the left. The word is move it to the left. We repeat this process until the current element is than greater than or equal to the previous element. Just keep repeating. We're checking the left all the way down until the element is greater than or equal to the previous element. And then if we continue this process, we at the end will get an entire list of sorted elements, right? Here is the example again. You will see the picture, and there is animation here for you, right? It's in the middle of the animation, so just check this. Two, we're checking on the left, waiting for the right place so it can be inserted. Say that we didn't switch the element, we just inserted for the right place. We're waiting for that, checking each and every one on the left, and then when you see this is the right place, we just insert it there. That's why it's called insertion sort, right? A little bit more, so you see that the beginning 5 is my second element. Check it. We need to move that element, and 5 goes the right place. Comes to the 3, checking with the 6. We see we need to move, but we need to check the 5, and then we'll find the right place. Check with the 1 again. 1 comparing with 6, we know we need to move. Comparing with 5, we need to move. Comparing with 3, we need to move, and then it goes right place. 8, obviously we don't need to move the swine. 7, we check with 8, and then you see we need to move. Check with 6, and we understand, okay, actually we don't need to move anymore to the right place. And same for the 2, is looking for the right place one by one, all the way down to the left, find the place. And the last one is 4, checking left item one by one, until it cannot move any more left, find the right place. So that's basically it. Now, with this information, with this knowledge, let's write the algorithm, let's write the Python code for insertion sort together. Okay. Okay. Before I write the actual insertion sort code, let me show you a little trick how really the memory in the RAM works. So let's write a simple code A, B, and C, 3 variables, and I'm giving some value to them. So 20, and let's say 10 and 5. Okay, this is the 3 variable. These are the 3 variables. A equal, it means A equals 20, B equals 10, C equals 5. Now, if I want to sort them manually, what could be done, right? That means A value needs to come in A here, and B is its right place anyway, and C 20 needs to go there. Now, of course, you might think, okay, let's just give A, just give C value to A and give A value to C, right? And that might be done. A, comma, B, comma, C, right? Just, it looks like that. Whatever in the C, give it to A. Whatever in the C, whatever in the A, give it to the C. Now, if you print it out, as you see what's happening, something is already lost. What is lost? 5, 10, and 5. C is lost because as soon as you are giving the value, C value to A, right? And then you are that value now given to the C again, the 20 is simply lost, right? Because 20 was in the A now, and that value is lost in between. What we could done differently. So here is the trick. As it is lost when you're giving to each other, I'm going to save that value, C value, somewhere safe. Okay, so the value of C, which is 5, is simply saved in a variable, right? After that, now simply I'm going to give this value C, B value to the C, and B is getting A values, right? Then A is getting keys value, right? I'll just show you now, and then I'll explain a little bit more. If you run this code, what happens, right? So at least 5 is getting this value already. Okay, we need to do one more change anyway, but think what happens. As we have lost the value, so the safest idea is we save the value somewhere first. Then when we are moving that value, like C is getting this value, which is 10, that's fine. I can, because C's value is somewhere safe. So I don't need to worry about how the C's value gonna be saved. It's gonna be lost, isn't it? And that is the reason I saved the value in a variable called key. And then, so B's value go to the C, which is 10. It goes 10 here. And B is getting this value. So we move this value. Remember the word I use, move, over and over? And that is the reason. We are not switching this value. We are moving this 20 to here. Then when this 20 is gone here, this value is gone here, I just simply give the value which is saved earlier to the A itself. So 5 now is in the A, 20 moved, 10 moved. Okay, if you just want to do one more, all you need to do again, make another key, save it, C value, then give C, B value to the C, and then safely the value is saved earlier, give it to the B. Now if you print it A, comma, B and C, if you run it, as you see, it's simply sorted nicely. So the simple idea is to move a value. Before you move it, you better save it somewhere. If you don't, it will be lost. As soon as you assign to the new variable, new value to the variable itself lost its previous value. So if you don't save it, it will be lost, right? So this trick basically we are going to implement in insertion sort. This is basically the insertion sort happening here very manually, but of course we need a proper algorithm, and then insertion sort can be happens, right? So now let's start with this understanding. Hopefully it will be easier for you to understand if you understand this. First I need a unsorted list. It could be anything randomly. Okay, I just give some numbers basically randomly. Now, of course, you're writing a function, and my function is insertion sort. Convenient name, it's gonna take a variable array. Okay, now we know that we need to go from this to the end, and we are starting from the second value, right? Which is index number 1. Remember, index number starts from 0. This is 1, 2, 3, and so on, right? So we are writing for loop. for I in range. We're starting from this value, the index number is 1. And where we are going down to here, that means we need to learn of array, right? Hopefully you understand this already. I'm not going to repeat it. My previous videos I already explained how it works, right? Okay, next. Now the element I'm working with 50, so is better. I'm going to save it somewhere here. I already showed you that. Okay, array of I. In the beginning, the first item we are looking for, which is 50, and I'm going to save it here. Then I'm going to create another variable, and so we can easily point it to the before value, before element of this I value, right? Now, the initial setup is done. Now I'm going to write a while loop. All right, I'll explain to why I need a while loop here. While the j value is greater or equals to 0 and array of j is greater than key. Okay, think a second. Now you already know what is j value. J value just point into the previous value. So if I value is pointing here, j value is actually pointing here. If I value is here, j value is just pointing here, right? We understand that. And as insertion sort going backwards, there is a chance that if you're keep going backwards, you might end up writing something index number -1, which is not possible. There is no index number called -1. So this is our first check. Next check is every time we are checking the value in the I position, which is the key, and the previous value is bigger than that, right? If it is, that means we need to move that, isn't it? So in that case, I need to write array j plus 1, and that value is getting this, right? I hope you pay attention to my example of ABC, how it works. If you understand that purely, it's now very easier for you to understand, right? What simply doing is here, let me write this code as well, and j gonna be going backward 1. Okay, so what's happening here? So we already know what is j. J means the previous element. J plus 1 gonna be the next element, right? So j is helping us to navigate the value from previous and next, previous and next, previous and next, like this way. If in any case this value is greater than the key value you are saving somewhere, so after saving that value, you just simply move that value to this position. So if the position was j, that position should be j plus 1. And that is the reason we are saying j plus 1 position is getting the value from the j position. One more time, this is my j, this is going to be my j plus 1. If this is my j, this is going to be my j plus 1. So if I need to move the value, all I need to do, write this j plus 1 position is getting the value from j position. And each time this is happening, we need to check the previous one, previous one, previous one, previous one, and that's what this is doing, right? J minus equals 1, another word, j equals j minus 1, right? It help us to go all the way backward. And now you'll see why this is important. Question is how backward it should go. It can be smaller than 0. It need to be stops in the zeros position because there is nothing before 0. So this code, this condition helps us to stop somewhere. Now, let me just clear it up. When all of the checking happens before that for any element, When it's done, again, we just safely give our key value, what we saved earlier, to this position. Okay, and then simply just return our array. Now, before I run it, I just want to explain this line a little bit more. So let's start with an example. Let's say I'm with this minus 1. Okay, this minus was my I, right? It is pointing, let's say the I is pointed to this position. Now j gonna be this, j plus gonna be this, right? Now, of course, minus I and 50 is larger, so 50 needs to move to this position. 50 needs to move to the j plus 1 position, right? And then we are checking the previous element. While this is not happening anymore, I need to insert the value, isn't it? So let's say we're going all the way down here, and all of them are moved already. My value minus 1 needs to come here, right? While j is greater than or equals to 0 in that position, now it's time, because my 150 is already gone to this position. 50 goes here, 100 here. This is now, I should insert my key. And then, so when you're going to the, let's say, in a position, j becomes minus 1, right? There is no position like this. J position is just pointing something here, which is not true. So if I say j plus 1, it is now pointing to the 0th index, which is this index. Now I need to insert my key, right? Please take a moment. It is a little bit thinking it. You need to think a little bit about it, really, how this is works. Remember, this is not part of the while loop. When you're done with the while loop, right? When you're done with the while loop, then in a position now, the key value is waiting to be inserted. Which position? The position when j is becoming minus 1, then only my while loop stops, isn't it? So j minus 1, there is no index number here anymore. So j plus 1, just bring it back to the 0th position, and we just put our key in there. We just insert our key in that position. Okay, and then when all of this done, you just return the array, right? And now if we print it, hopefully it will show me there is a line number 6. Let me fix it. Oh, it should be I minus 1. Sorry, guys. Because if this is I, j should point the I minus 1 previous value. All right, now it's working. Minus 10, minus 1, 145. Yes, it's working. So I do. There is a little trick you need to understand in here, few lines. So please do take your time, write this code several times, and manually just try to track. Maybe just write these three elements there, and manually try to track what's happening in the for loop and what's happening in the while loop. Why you're inserting the key value in this position. J plus 1 actually pointed to which position when while loop stops. Okay, just think small, three numbers, then it will be clicked in your mind. Right? Hopefully that helps, guys. Thanks so much.